Good morning all. Today we are learning the basics of electromagnetics. In that we are learning the basic law of electrostatics, which is Coulomb's law. So Coulomb's law, given the two equations, or he has given the statement that if there are 2 point charges, like there may be like charges or they may be unlike charges. So if I assume that there are like charges are there, so there is a force of repulsion. Here you can see Q1 is a positive charge, whereas Q2 is a positive charge. So there is a force of repulsion between charge Q1 and charge Q2. Coulomb states that if the charges are like charges, there is a force of attraction. So Q1 is a positive charge and Q2 is a negative charge. So you can see over here there is a force of attraction between the 2 point charges. So basically this law states that between the 2 point charges, either there is a force of attraction or there is a force of repulsion. Is depend upon the nature of charges. So this force we can find out with the help of this equation. This equation states that this force is directly proportional to the magnitude of charge 1 and magnitude of charge 2. What we are assuming, there are 2 point charges Q1, Q2. They are separated by a distance r. Assuming there is a charge Q1 and there is a charge Q2 and they are positive charges and they are separated by a distance capital R. Then we can find out the force F is directly proportional to Q1, Q2 and it is inversely proportional to the square of distance between the point charges. Again, this force is depend upon the in what medium you have kept the charges. The magnitude of the force is also depend on medium. So if combining these two equations, I can say that this force is directly proportional to Q1, Q2 upon R square, and we can use the constant of proportionality as K over here. We will see on how it will depend on the media. So for this, we have to consider the constant of proportionality K as 1 upon 4 pi epsilon 0, where epsilon 0 is the permittivity of free space and the value of epsilon 0 is 8.84 into 10 raised to minus 12. So after substituting the value of epsilon 0, the formula is slightly modified as F is equals to 1 upon 4 pi epsilon 0 Q1 Q2 upon R square, and the unit of force is Newton over here. But there are certain limitations of Coulomb's law. So the first limitation of Coulomb's law is this Coulomb's law we can apply only to the point charges, because charges may be in the form of line charges or it may be form of surface charges. But this law is only applicable to the point charges. Then second limitation is you can apply this Coulomb's law to the stationary charges. If charges are in moving condition, we cannot use this Coulomb's law over here. But as we know, the Coulomb's law, force is a vector quantity. So we have to consider magnitude as well as force over here. The second condition is if there are multiple point charges are there, like here Q1, Q2, Q3 are the 3 point charges are there, and we want to find out the resultant force acting on charge Q. So in that case, we have to use the principle of superposition over here. So what is that principle of superposition? We have to find out the force acting on Q due to the Q1, which is called F1. Then find out force acting on Q due to the charge Q2, which is F2. Then find out force acting on charge Q due to Q3, you will get F3, and you have to do the vector addition of all these forces F1 plus F2 plus F3. So resultant force is given by capital F is force because of the charge 1, force because of the charge 2, and force because of the charge 3 over here. So this way I can find out the resultant force acting on charge Q over here. Then we'll try to solve a numerical based on the Coulomb's law. So what we assume that there are the 2 point charges. The value of point charge Qn is 2 millicoulomb, which is located in a free space at a point P1. So coordinates of point P1 is given over here. While second charge Q2 is pi millicoulomb, which is located at point P2. Then question is find out the force acting between the 2 point charges, that is F2 bar and F1 bar. So straightway we can use the formula of the force acting between the 2 point charges. So if I assume over here the point P1 is at -3, 7 and -4, whereas point 2 has 2, 4 and -1. So first we will try to find out the force F2 over here. So to find out F2, this is my formula, like F2 is equals to Q1 Q2 upon 4 pi epsilon 0, then the distance square into that unit vector. So here the most important is you have to find out the magnitude or the distance between the charge 1 and charge 2 and the direction vector. So easily we can find out the vector directed from P1 to P2, and then we can find out the direction of that vector. Simply put all the values, and at the last you will get the resultant force which is acting from charge Q1 on charge Q2. So this is all about how to find out the force between the 2 point charges. They are separated by distance r over here. So thank you.